little bit tomorrow for a quiz on Friday. Okay, so let's practice like we did yesterday. So remember I gave you those practice quizzes yesterday? And we did the first two. Let's do the back side now. It has a couple more. We're verifying these. On your quiz on Friday, you will have to do one verification problem. Okay? So you're going to have to do one of these all by yourself. Yesterday we practiced 2. Today we're practicing 2. In the video tomorrow you'll practice another 1 or 2. You have to do this on your quiz.
I'm ready.
Oh, you know what to do?
I'm helping you.
All right, thank you, Jake. What do you want to do with this?
We, what's it called, factor out the top left?
So the top of this, I want everybody to look at it. The top of that is a quadratic. It factors just like quadratics have factored since, Algebra 1. How does that factor? 1 and 1, right?
Yep.
I'm going to need a minus and a plus. And then what? What times is the 4 and adds to 3?
Minus 4.
Minus 4 cosine and plus 1 cosine.
Yeah.
If you are struggling with it with the cosines in there, think of it as 1 minus 3x minus 4x squared. How would you factor that? It's exactly the same problem. Now, the denominator does not factor, and furthermore, the denominator is a sine, but I'm wanting to end up with a cosine. Now, luckily, that's a sine squared. What do I know about sine squared? I heard somebody say it, 1 minus cosine squared. Exactly. Because of that identity that says sine squared plus cosine squared is 1, we know that sine squared is 1 minus cosine squared. Right? Now, tell me about 1 minus cosine squared. It also factors because it's the difference of squares. The difference of squares always factors. How? 1 plus cosine, 1 minus cosine in either order, doesn't matter.
There you go.
Yep, and what's going to happen?
Cancel.
Those are going to cancel. Remember, you do not cancel until you factor. You have to factor before you cancel. So don't be thinking anything's going to cancel until this step right here, when you get a factor. All right, so 2 important things in that problem to kind of store in the back of your mind. One is sine squared is 1 minus cosine squared, and vice versa. Cosine squared is 1 minus sine squared. Second is, these things factor, when they're squared like that, they factor just like regular quadratics. And that worked out great. Okay, what about the one down there at the bottom? All right. What do you need to change it? Yeah. Okay, I love Sydney. She's into this. She likes these things. She says, should I change these into sines and cosines first, or should I get a common denominator first? And the answer is, they're both great plans. Doesn't make any difference. Now, personally, I would change it to sines and cosines first. But you could, right off the bat, get a common denominator if that's what you wanted to do. I think I'll go ahead and change it to sines and cosines. Is that all right? So what's tangent? Sine over cosine. And what's cotangent then? Cosine over sine. Alright, plus, now this is one fraction. Alright, then we got this one, which is going to be cosine over sine over 1 minus sine over cosine. Now, I know what you're thinking. You're thinking, oh my gosh, that's a mess, and it is. But this thing right here is called a complex fraction. We talked about this the other day. What can I do that's pretty easy that would clean this mess up? Multiply everything by the common denominator of the whole shebang. Okay, so what's the common denominator of the whole thing? This fraction in the circle, what would be the common denominator of all those parts? Sine and cosine. So I'm going to multiply everything by sine and cosine. All right, so what does that leave me with? What do I have left on the top? Anybody wake out there? The cosines cancel. So I'm left with sine squared, yep. Over sine cosine, nothing to do with that. Minus cosine squared. Everybody okay with that? All right, let's see what happens over here. Should I multiply by the same thing since the denominators are the same here, sine, cosine? Don't forget the 1, you gotta multiply him too. So now we're gonna end up with cosine squared over sine, cosine. Sine squared. Alright, let's look at this for a second. Can I factor anything here? Alright, so what's going to happen if I do that? I'm left with sine minus cosine. Right. And can I factor anything here?
Sine.
Okay, now things are starting to come together. It may have been easier to get a common denominator first. We didn't. I didn't. My bad. It was my choice. So here we go.
Could you get a common denominator in the top there? Like, so.
Up
where you
here?
at? Yeah, could you do that with a common denominator?
You know, I absolutely could, but I think it's going to be easier, Jake, because to do it here, because these two are actually the same thing, just backwards of each other. So if I multiply this one by a -1 over -1, so top and bottom by -1, it's actually going to turn this around and make it sine minus cosine.
Yeah.
Does the sign in front not have to become negative?
Does the what now?
The sign in front of that, how does that not have to become negative?
Because I put it up here.
Oh, I see.
So I times the top and bottom by -1, and that flipped this around, and then there's the top one. See, if I put -1, -1, if you distribute this -1 to this guy right here, it becomes negative cosine, positive sine, which is what I've got right here. Oh yeah, we're getting it now. Things are looking really good now. So on the top, we have sine squared, we have sine squared over cosine, sine minus cosine squared over sine minus cosine. All right, now it's easier to get a common denominator. What will my common denominator be? This one will need to be times by a sine. I'm going to go ahead and finish this, and we're going to go back and do it the other way, because now we're going to have to factor cubes. And I don't know if you remember how to do that or not. So this one times by cosine. Try to stay with me here. I've gotten us into this mess. We got to get out of it. So we have very close to a common denominator here. We just need to put a sine here and a cosine here. So that's what I did. Does anybody remember how to factor the difference of cubes? Those are cubes. Does anybody remember how to do that? Does the word soap?
Same opposite, always positive.
Same opposite, always positive.
So good.
What? All right, so tell me how to factor
Oh, I
it.
never said I could
Since
do this
I'm
one.
so
I said
good
I
at
used to be
it.
so good at this. These used to be my
Okay.
favorite ones.
These are your favorites?
My favorites.
Let's start back up over here, I guess. Okay, so when we factor the difference of cubes, we take the cube root minus the cube root, so it's gonna be sine minus cosine. And then we square the first one. We multiply them together, and we square the last one. And then this is where the soap comes in. That sign is the same as the problem. This one is the opposite, and this one is always positive. All right, so in case, put regular letters with it, x cubed minus y cubed is x minus y, x squared plus xy plus y squared. That's how we factor the sum, or the difference of cubes. Well, why is that so great? I mean, the problem is a disaster for sure, but things have, I mean, now it's in really good shape now, because what happens?
It cancels.
This part's gonna cancel, and what's that?
1.
So on top, we have 1 plus sine cosine, and on the bottom, we have sine cosine. Now, please don't cancel at this point because of that plus sign. But you can uncommon denominator it and write it as 2 separate fractions. And now you can cancel it. I erased that, I don't know where I'm going. Oh yeah. So this is cosecant secant. And that, I think, is what we were trying to end up with. I have it backwards, but isn't that what we wanted? 1 over sine, 1 over cosine, that's your cosecant secant. And plus 1. Wow. I want to go back and see what would have happened if we would have chosen the other way. So the other way, she said, let's get a common denominator right off the bat. So we ended up getting a common denominator, but let's do it right from the beginning. So the common denominator will be 1 minus cotangent, 1 minus tangent. Okay. So this guy, hey, pay attention guys, you're gonna have to do one of these. This guy has to be multiplied by 1 minus. And that guy has to be multiplied by 1 minus. Alright, Alright, so I kinda did it all at once, but I got a common denominator, so I multiplied this one by 1 minus tangent, and I multiplied this one by 1 minus cotangent. Alright, now what should we do? Since we have our common denominator now, what should we do? How about we distribute? So tangent minus tangent squared plus cotangent minus cotangent squared over 1 minus tangent minus cotangent plus 1. What happens when I multiply a cotangent and a tangent? They cancel, don't they? Because they are reciprocals. Alright, now what? You guys were making fun of the way I did it. What do you want to do now?
I don't know. You're putting the sine and cosine now?
We absolutely can, but what a mess that's gonna be, but, I know mine was a mess too, so oh well. Alright, here we go.
I got one. Doesn't the 1 and the 1 on the bottom cancel? Or with the 1 minus 1?
I think they're both positive, aren't they?
Oh yeah, you're right. 2.
They make 2 for sure. I'm wondering if, when I get a common denominator, or when I clean up this complex fraction, I wonder if it's gonna take me right back to where I was before. Because to clean this up, I'm gonna have to multiply everything by cosine squared, sine squared. And I'm seeing my cubes come back in, so I don't think I'm gonna continue on, because I think it's gonna be just like it was before. I think we're gonna be right back to where we were before. So anyway, that's a good problem. Took us a while.
Took you a while. We didn't do much. I'm not gonna lie.
Well, sometimes we just go as far as we can, and then we just get stuck. Here, we gotta practice a couple more though, because you're gonna have one of those, but you're also gonna have one of these. All right, guys, we're gonna have to solve this. Okay, this is not a verify, this is a solve.
Minus 3. Plus 3.
Probably add 3
Yeah.
and divide by 4. And then what? Square root both sides, remembering that when you square root, it's plus or minus. And this would be the square root of 3 over 2,
Yeah.
which are numbers that you recognize. Which quadrants, you're not done, you're finding the angles, you're interpreting an angle. Which quadrants can this angle be in if its sine is positive or negative?
1 and 3 are 4. All of them?
All of them. The sign is positive up here, and it's negative down here. It's plus or minus, it's everywhere. And opposite is root 3, and hypotenuse is 2. How big is that reference angle for a triangle like that? 60. But we are in radians for this problem, so instead of 60, we'll say pi over 3. So all of these angles are pi over 3s. So in quadrant 1, the black one there, it is pi over 3. But what about my red one here? Over here in quadrant 2,
2 pi minus pi over 3?
not 2 pi,
Oh, pi.
pi minus pi over 3. So pi minus pi over 3 will be 2 pi over 3. Think of them as regular fractions. 1 minus 1/3 is 2/3. Okay, what about my blue one now, down here in quadrant 3?
4 pi over 3.
It's pi plus pi over 3, so it's 4 pi over 3. And then, what about my orange one, all the way around to here? That one is 2 pi minus pi over 3, or 5 pi over 3. Everybody okay with that? All right, ready, one more of those, one more equation. 2 sine squared plus 5 sine minus 3 equals 0, and we're doing this one in degrees. That doesn't change a thing about how we do it, it's just how we answer the question. All right, so what do you think about that one? Nyla?
Subtract 3/4.
Well, it would be adding it, and I probably wouldn't, because this equation is quadratic, and I like to have my quadratic set equal to 0. So probably if the problem had started like this, Nyla, the first thing I would have done would be to subtract that 3 over to get it equal to 0. Well, I kind of gave you a huge hint there. It's, yeah, I mean, I'm gonna factor it. It's quadratic, right? It's quadratic. So one way of solving the quadratic is to factor it. Anything I give you will be factorable, unless it's a bonus or something weird. So how does this one factor? Okay, I'm not
2
helping
sine.
you. But yeah, if you're confused, think of it as 2x squared plus 5x minus 3. How would you factor that?
2 sine.
2 sine x.
Sine x.
Sine x.
The first one would be minus 3, the second one would be minus 1. No, because this is the funniest.
Plus 3 minus 1. Because you need to get the 5 somehow. It's 3 times 6.
Plus 1 minus
3 times 3 minus 1. Something like
Do
that.
we have flip those?
Now,
negative
it's,
1 plus.
this could be a quiz question. This is not that hard. You need to be able to factor your trinomials. Okay? You need to be able to factor so that when you FOIL it back together, you get whatever the original problem was.
Flip those times.
So this is gonna, whoop, that needs to be a plus and this needs to be a minus. How about that? Because that gives me a positive 6 and a negative 1.
Did it.
All right. Well, no, we're not done.
So that was a big
Now
part
what
of
do
it.
we do?
Now you have to start with
So
0.
now sine x equals 1/2. I'm gonna set this one equal to 0.
Yeah.
Write out as many steps as you need. Sine x is gonna be 1/2. Or sine x is gonna be -3. All right. Where is the sign positive? Now that's just the positive. It's gotta be quadrant 1 or quadrant 2. Because sine is associated with y, and this is where y is positive. So opposite is 1, hypotenuse is 2. What kind of an angle is right there? 30 and 30. So the answers to that are 30 degrees and 150, 180 minus 30. Okay, where is the sign negative? Obviously, quadrants 3 and 4. Now wait a second. Wouldn't that mean that the opposite side is -3 and the hypotenuse is 1?
Yeah.
Does that bother you?
Yeah.
Can that be? No. This gives you extraneous. There are no sine values bigger than 1. You can't have a sine be 3. That doesn't make any sense. It's impossible. So the only answers to this problem are 30 and 150. Okay? All right, we're back at 49, and we'll finish up our notes for 5-3.